Welcome to this explainer. I'm so thrilled you're here because today we're unpacking something absolutely massive. I want you to picture this cinematically in your mind's eye. Right now, as you're sitting there, you are completely surrounded by an invisible nervous system wrapping around the entire globe. We're talking about the Internet of Things, the IoT, and specifically the cloud platforms that act as the brains behind the whole operation. Get ready, because we're going to visually trace the exact path your data takes, soaring from a tiny sensor in your room straight up into the digital stratosphere.
All right, section 1, the connected world.
So imagine the camera panning back. We're pulling way back from your smart thermostat, past the automated factories, all the way out into orbit. What do you see looking down? 14 billion invisible threads. 14 billion. That is the sheer number of IoT devices currently connected worldwide today. Literally every single one of those devices is tirelessly collecting data, automating processes, and feeding info back to us in this vast ocean of real-time communication. It's wild. Now let's fast forward just a few years to 2030. That web completely explodes to 25 billion. The growth of this planetary nervous system is absolutely epic, and honestly, completely unstoppable. But it brings up a really critical question. With billions of machines all shouting at the exact same time, how do we avoid total digital deafening? Let's look at section 2, the IoT middleware layer. Okay, so to prevent total chaos, we rely on what's called a powerful middleware layer. Think of it as the ultimate digital traffic controller, seamlessly bridging physical devices to user applications. It handles device management, real-time analytics, and enterprise integration so smoothly that a project can scale from 100 devices up to millions without completely crashing. But here's the truly staggering reality. 80% of this global infrastructure is locked down by a tiny handful of massive entities. We call them the hyperscalers. They collect, hold, and process the lion's share of the entire world's IoT data. Moving right along, section 3, Titans of the Cloud. These platforms are the absolute heavyweights of the digital sky, and they each bring very different strengths to the table. Let's visualize them. Think of AWS as this impenetrable, pay-as-you-go digital fortress, absolutely packed with comprehensive services and super robust device management capabilities. Now, contrast that with Google Cloud, which acts more like a vast, open, experimental laboratory. They actually offer students 15 gigabytes of free space to build heavily integrated machine learning projects, making it incredibly easy to spot trending analytics directly on your dashboard. Then you've got Microsoft Azure, acting like a massive, bustling corporate headquarters. It effortlessly manages edge devices globally across these huge enterprise grids. Cisco, meanwhile, that's the digital vault. It's a highly locked-down, network-centric fortress built for maximum enterprise protection and heavy security protocols. And beyond these giants, you have specialized intelligence hubs too, like IBM Watson, leaning heavily into AI for cognitive computing, or Oracle, providing rapid-fire, real-time analytics designed specifically for business intelligence. Which brings us to section 4, specialized IoT platforms. Look, you don't always need massive scale. Sometimes you just need speed and highly targeted functionality. Take ThingSpeak, for example. Picture it like a giant data funnel, pouring raw numbers directly into deep mathematical analytics and MATLAB visualization tools. On the flip side, Lassant is kind of like a set of digital puzzle pieces. It's a highly flexible, low-code enterprise environment where you can visually snap together your operational infrastructure on the fly without getting bogged down in endless lines of written code. Let's get hands-on in section 5, connecting the hardware. Let's leave the global stratosphere for a second and zoom all the way down to the micro level. A single microchip and a temperature sensor sitting quietly on a board. I want you to treat this physical hardware wiring process like the first phase of a cinematic heist. Step 1, we connect the power. That's the lifeblood of our sensor. Step 2, we wire the ground to complete the circuit. And finally, step 3, creating the payload pathway. We secure the data pin to the microchip, essentially setting the trap so the sensor springs alive. Okay, now for the digital extraction. First, our chip reaches out to the local Wi-Fi. Once it's connected, it flashes its digital ID badge, a completely unique API key pulled right from our dashboard. With clearance granted, it executes the command, securely grabbing our temperature data and beaming it straight up into the cloud. Boom, a perfect extraction. And just like that, our single, tiny sensor's data joins the 14 billion other threads pulsing around the globe right now. You've literally just seen the nervous system of the planet from the inside out. So, armed with this knowledge, what are you going to connect to the cloud next? Thanks so much for exploring this with me, and I'll catch you in the next explainer.